In this video, we will discuss about the annuity. Annuity is your equal payments at equal interval of time. That is, if you have taken a loan and you need to pay equal payment at equal interval of time to repay that loan, so then that is an annuity. Or if you are paying equal payments at equal interval of time to get a certain amount in future, so then that is an annuity. For example, if you are paying $500 every month to get a certain value after 10 years, so then it is an annuity because $500 you are paying every time, equal payments, and you are paying every month, so at equal interval of time. It can be a loan or it can be an investment. Now, annuity can be of different types based on the payment period and based on the interest compounding period. So we can classify into two types first, ordinary annuity and annuity due. Ordinary annuity payments are done at the end. Annuity due payments are done at the beginning of the period. Now, ordinary annuity can be of two types, ordinary simple annuity and ordinary general annuity. Ordinary simple annuity where the payment period and interest compounding periods are same, whereas ordinary general annuity payment period and interest compounding periods are not same. And annuity due where the payment period and interest compounding periods are same, and general annuity due where the payment period and interest compounding periods are not same. Now we will discuss here ordinary simple annuity first. That means the payments are always done at the end of the period and payment period and interest compounding periods are same. Now, example of annuities, it can be residential mortgages. So, if you are taking a house loan and you are paying mortgage, so you will pay every month equal amount every month, right? So, equal payments at equal interval of time. Same thing for car loans or lease, student loan payments. So, each of them involves equal payments at equal interval of time. Now, typically the payment periods are monthly, quarterly, semi-annually, or yearly, just like the interest compounding period. Now, because we are dealing with ordinary simple annuity, so we can see that the payments period, that is when you are paying the amount, a regular payment, and interest compounding period, which you already know how to calculate, that is M. So that will be same. So we know that that also can be monthly, quarterly, semi-annually, and yearly. So now future value of an ordinary simple annuity can be given as it is denoted by FVN, which is equal to PMT 1 plus I exponent n minus 1 over I, where PMT is the regular payment paid equal payments at equal interval of time. So that is your PMT. I is the periodic rate of interest, which is J over M. You know how to calculate. And N is the number of compounding periods for the whole year. Or you can also say it has a total number of payments here for annuity. So both will be same because number of compounding period, it is the same as your payment period. The total number of payments we can calculate and we can find the N. So let's see an example. Payments of $1,000 each are made at the end of every year for 5 years to a savings account. Calculate the accumulated value or future value of the account at the end of 5 years. The interest rate is 6% compounded annually. So here the regular payment is $1,000 and you can see the payments here is $1,000. This is given. And then we have the payments are done at the end of every year. right? And for 5 years. To a savings account, you have to find the accumulated value, means future value you need to calculate. What will you will accumulate at the end of 5 years, and 6% compounded annually interest rate. So you can find the payment interest compounding period is annually. Interest compounding period and the payment period, it is the same. So you can see it is your ordinary simple annuity. So where the payment period is every year and interest compounded also every year. So therefore, it is your ordinary simple annuity. Right, so what we have, we will write it here. So we have PMT is equal to 1000. We have I is equal to 6% compounded annually, so it is 1. So it is 0.06. And then we have n total number of payments. So 5 years, each year you are paying, so it times 1. So it is total number of payments. So we have PMT, I and N. So we will use this formula to calculate uh, the value. So that is PMT 1 plus I exponent N minus 1 over I. So you can substitute the values and then calculate. Make sure you follow the bedmass rule. That is, first larger bracket, in that larger bracket you have a smaller bracket here, then exponent and minus 1. So you will get the numerator divided by this one. You will get this bracket value that multiplied with PMT will give you the future value. So you will get this value here. So you will get it 5637.09 if you calculate. So let's see in the calculator how to calculate this. So we have smaller bracket as 1 plus I, which is 1.06, and then exponent 5 minus 1. So this is your numerator divided by 0.06, which is your bracket value, and multiply it with 1000. So you will get the future value. Rounding till two decimal place, it is 5637.09. So using financial calculator, first we will set the payment period and interest compounding period as 1. So we will press the second and then this P over Y. So payment per year, it is annually. So and we can, it is already 1, so we can press enter. Press the arrow key down. So you will see C over Y, which is again annually, and then again press enter and then press second and press quit. So we set the payment period and interest compounding period as 1. Now we will enter all the given data. So first the value and then this TVM keys. So here first we have N. So N is 5. So 5 and then N. So first press 5 and then N. Then I over Y, which is interest per year. So which is 6% per year. So 6 and then I over Y. We don't have present value here, so we will press 0 as your present value. PMT, regular payment, and because you are paying, so PMT will be always negative. So it is negative and then press PMT, and now you will press compute future value. So press compute and then future value. So you will get the same future value what you got it in using formula. So another example, you deposit $10 at the end of each month for 5 years in an account, paying 6% compounded monthly. What will the balance be in your account at the end of 5-year term? How much of the balance will you have contributed and how much is the interest? So you are depositing $10 every month for 5 years and interest also compounded monthly. You are paying monthly, interest also monthly. So therefore it is your ordinary simple annuity. You're depositing $10, so that means PMT is 10. Your I is 6% compounded monthly, that is 6 over 12% is your I. And your N is 5 years. Every month you are paying, so 5 times 12, which is 60. Now you have all the data, so you will use the future value formula to calculate the future value. You will substitute here all the values and you will see that you are getting 697.70. So follow the same rule of calculation using the calculator. If you are using the formula, follow the BEDMAS rule, or you can also use the financial calculator to calculate it the same way how we have done the previous problem. How much of the balance will you have contributed? So you are contributing $10 every month for 5 years. So actual contribution for you is $10 every month and for 5 years. So it is total you contributed is $600. So you are paying $600 here and you are receiving 697.70. So how much interest did you receive? Is the difference, which is $97.70.